Okay, now it's time to check out the processes we are going to be using in mechanical physical separations. And of course, these are not the only ones, and this does not mean also that these are the most common ones, but are the ones that I think are more relatable to process engineering. And we start with flotation. As the name implies, we're going to be forming a froth, and there will be flotation of the solid particles. And what you want to do is, for instance, remove the froth, which already contains the particles. In a successful flotation system, you're going to be removing the particles this way, and the final products are going to be at lower concentrations of the solid, or maybe even at no concentration at all. Flocculation is a process which is very commonly used after coagulation. Okay, no, we don't have it, but typically you have the particles in colloidal suspension. And when we add certain type of materials, for instance, coagulants or flocculants, what's going to happen is that the particles are going to start binding together. Eventually, they start forming larger packs of molecules, for instance, flocculation. And you get to the point that they are no longer on the, let's say, on the light point in which they can flotate, so they will start dropping, meaning that they will start forming sediments, or sedimentation is going to occur. Talking about that, let's exploit the concept of sedimentation, and once the solids are forming on the bottom, you can let them settle and eventually remove the solvent. Some type of processes might include decanting. So for instance here, if you already added your coagulant or flocculant and the material started to form sediment, which is called the sludge, you can remove the material already free of solids, and this will be a type of decantation system. Other type of decanting systems are as follows. You have the system, you let them sediment, and you just remove the top layer and let the bottom layer on the process. Another example of how you can work with the sediments or the particles is via filtration, depending on which type of process or whether conventional filtration or cross-flow filtration you're using. But the main idea is, of course, to remove the solid particles and let the solvent to pass. Then we continue with centrifugation, which takes advantages not only on the difference in densities. I'm pretty sure that you already know that centrifugation of blood is a very common example. If you allow blood to separate due to gravity alone, you will never get this part right here, because the interaction between the materials or the density difference is not good enough. You need more strength or more force. The force of centrifugation is going to allow us to separate these type of solutions. Cyclone separations are also very important. We already saw a little bit on cyclones, on washers. The main idea is that you add the air and you force the air to shock within the equipment. And what's going to happen is that all the solid, and you already know that solid is a heavier material or more dense material, it's going to fall, while the clean air is going to go on top. Magnetic separation is also a very important aspect to consider, because if we are talking about materials which show magnetism, such as iron, aluminum, and so on, you can separate it via this way. And probably you think this is very childish approach because you remember using magnets alone, but remember being at a industrial waste place, this magnetic separation is clear one of the top separation processes involved. We're going to also show mechanical size reduction, and it's very important, especially when you want to obtain important material. For instance, here we got hematite ore. As you can see, it's technically stone. So what you need to do is start crushing it, then you keep crushing it, vibrating, until you bring it to the mill, spiral classifier, magnetic separation for the magnetic material. You dry it, and what you end up is with a final powder, which is very valuable in the market. And then we keep with mechanical size reduction. This is another example on how it works. You have primary ore, You have the jaw crusher, hammer crusher, spiral classifier, which is going to be classifying on size, and so on. The end products are as well these part here. And it's very important. I remember why I added this image is because I wanted to show you the flotation system that they use in order to obtain the material, and also a thickener. Remember that we already saw that as well. And the sieve system. Sieve system is nothing more than a system of filters or mesh sizes that will allow certain size of materials to pass through and other materials not to pass through. So let's say that we have a mixture of solids of the following sizes: gray, orange, blue, and red. You start throwing them here, so the first material is not going to be able to pass through, the gray one, so it goes out. Then we go the orange one, which passes through and then will not be able to pass in the second mesh. The blue one is going to be able to pass, but will not be able to pass in the third one. So what you end up is having a system which is separating very efficiently these four materials.